In this video, I'm going to go over finding and proving inverses. You can find this problem in your Unit 2 packet on page 16. So in this problem, we're given a square root function, and it's already in y equals form. So we're just going to rewrite it. Instead of y equals, we're going to rewrite it as f of x equals. If the y wasn't isolated originally, you would first have to isolate the y and then replace the y with f of x. Okay, next thing now we're going to find the inverse. So in order to find the inverse, you switch x and y, and then you isolate the new y. So we're going to write x equals square root of y plus 1. Now, because that y is under a square root, we have to do the inverse of taking the square root, which is squaring it, in order to get rid of the radical. So I'm going to square both sides. And that will leave me with x squared equals y plus 1. And then I just need to minus the 1. X squared minus 1 is y. All right, and then lastly, you do want to write it in function notation. So remember that the notation for the inverse would be f with a little -1 exponent of x, and then you can just write the function. Okay, so that's the inverse, we think, we hope, but now we have to do the proof of it. So in order to do the proof, you have to do two compositions using the f of x and the f -1 of x. It doesn't matter which way you do the composition first, you just have to do it both ways by the end of the problem. So we can just start with doing f of -1 of x. And then we'll just swap them for the next proof, for the next part of the proof. So here what we're doing is we're plugging the inverse into the original. So we're using this function and we're using this function. I'm just going to rewrite it, f -1 of x. Okay, so I'm plugging into the original. So I'm going to have my radical, and it says x plus 1. So instead of putting that x, I'm going to replace the x with x squared minus 1, because that's my input now. And then I'm going to just put that original plus 1 back on the end. Okay, so as you can see, these ones, well, the 1 and the -1 are going to cancel. So that just leaves us with square root of x squared. And when you take the square root of x squared, you just get x. And that's what we wanted. We wanted our answer to be the original input for the problem. So that's good. Okay, now we have to do the same thing, but we have to do it in the reverse direction. So we're going to do now f -1 of f of x. All right, so now I'm plugging my original into the inverse. So you'll notice the inverse starts with x squared. So what I'm going to do is I'm just going to plug in my original, which is x plus 1, and I'm going to square it because it says x squared, and then I have a -1 at the end. It's important to show every step when you're doing these because you know the answer is supposed to be x, so you have to show that you can truly get that algebraically. Okay, when you square a radical, it's just going to be what's under the radical. Okay, like before, these ones are going to cancel. And so then I'm just left with x, which is what we wanted. Okay, so now finally you need to just write a statement just stating that they are in fact inverses and stating why. So let me pick a different color. So now at the end we're going to write, therefore, f of x and f negative 1 of x are inverses because, okay, so this is where you have to write a long statement. So it's because f of f negative 1 of x equals x, which equals, and then you write it the other way, f negative 1 of f of x. Some people like to put the x at the end. It does not make a difference. I mean, I guess you could even write them separately and say like that each one is equal to x, but I like to write it like this, and I stick the x in the middle, just showing that they both equaled x. Okay, so that's your proof. So it's really not a lot. Just in the past, a common mistake that kids make when they're asked to prove that something is the inverse, they show how they switched the x and y and they isolated y. That's not the proof. Everything to the right of my squiggle, that's the proof. Okay, so it's important that you keep that in mind. Okay, thank you for tuning in.